For this upcoming lesson, we're going to be going back and taking a quick view of material that you should have learned in Algebra 1 involving solving inequalities and also absolute value equations. Now, solving inequalities, we are basically going to be extending what we discussed in solving equations in the previous lesson. So really, this should not be too much more than what you've done already. There's a couple of high points I want to hit out, and so these videos should kind of go a little quickly, and I'll take you through some sample problems here. But I want to point you out, first of all, to this key concept graphic with the basic inequality statements. And what you'll see are the graphs. And I want to remind you that we're no longer going to use the open and closed disk, but we're going to use brackets in place of those disks, similar to the interval notation that we've been working on. So it's very important that you keep that in mind whenever you're graphing these inequalities on a number line. So if we move down just briefly here and touch on a point, one of the things that's different with inequalities than regular equations is when we multiply or divide by a negative number. If you recall from Algebra 1, this is actually going to reverse the sign, and so you want to make sure that when you do this that you don't forget to reverse that sign. That can affect your total solution set. So let's take a look at sample problem number 1. Now, I didn't give you an example in this, figuring that solving equations was probably a good review. We're just adding in an inequality here. And you can use the previous graphic to help you with the graphing. So go ahead and pause the video and work sample problem number 1, and then come back and look at the solution. Okay, so if we work this as a basic equation, I'll start with my original inequality, and if I'm working this like an equation, I'm going to have all the same properties of equality that I used before, except with an inequality sign. So I'm going to start by adding 9 to both sides. And then of course you can see here, and I'll just put this in for effect, we're actually dividing both sides by -3, so that gives me a good visual. And so that's going to leave me x, and then of course, because I divided by a negative, that's actually going to change the direction of the sign. So I'm going to have x is greater than -3. Now, you can just sketch a graph. I'm not looking for precision here, or a bunch of little marks on this. So the way I just basically sketch this is I will actually put in the numbers that we're working with, and you can see here that all of the x values are going to be greater than -3, and it's not equal to -3, so that's going to be a open bracket, and I'm just going to use a little highlight tool to show shading. I know that's not the best way to do the shading, but you get a sense of where the solution set is. And now this number line actually gives me a good lead-in into my interval notation to write the solution set. So I'm going to use open brackets with -3, and then we're never equal to infinity, so that also has an open bracket. Okay, so that's the first sample. Hopefully you did that fairly well. We've added one more here, a word problem, in sample problem number 2. So for sample problem number 2, you need to create your own inequality. So that's probably the challenge here. So let's take a moment to try to work that problem and then come back and take a look at the solution. Okay, so the first thing I'm going to do is define my variable. So I'm just going to say n is equal to the number of movies that we would rent. And I have 2 different plans, and so my first plan is just a direct $36 fee. And my second plan actually has the option of a $15 a month fee plus $1.50 for each movie rental that I have, and so that's my end value. Now, I've set up 2 separate expressions to represent the 2 individual plans, and so finally it asks me how much must I rent for my first plan to cost less than the second plan. And so I'm going to take a look at setting up an inequality like that. So my first plan here is $36, and I want it to be less than the second plan. And now I just go about solving the inequality for n, and so I'll work through that now. So basically what this is telling us is that we need to rent more than 14 movies to make the first plan worthwhile. So, okay, that's a quick introduction to inequalities, and we'll come back in the next video and we'll discuss the compound inequalities. So now we'll move on from basic inequality statements to what we call a compound inequality sentence. And if you recall, a compound inequality sentence is basically two simple inequalities either combined together with an and or an or statement. So this should look somewhat familiar to you from Algebra 1. You may need to review some basic rules here, but we need to add in here the idea of writing the solution set either in set builder notation or interval notation. Now, of course, we're going to continue to use more prominently interval notation, as that's what you'll be using more going forward. So we have a first example here that uses the and statement, and so I wanted to kind of point out a couple things in regards to the and statement. First and foremost, an and statement tends to give us what's called a bounded interval, which means that the solution set is not going to go to infinity. It's going to actually be broken off at certain endpoints in the solution set. And so basically how we would do this is we could solve each individual simple inequality separate of each other, and then actually graph the two separate of each other. And you can see in this example where we have the red graph and the light blue graph or the teal graph that individually they would basically overlap, and it's that overlapped portion that actually creates the solution set for this compound inequality. And you can see here in the diagram that it says and means that a solution makes both inequalities true. So since there's an overlap portion, the solution has to work for both inequalities. Now, if we have the same algebraic expression in both simple inequalities, we can actually collapse that down to a single range that we would use for an inequality, and you can see that example here down at the bottom. And so that's a good look at an and statement compound inequality. Now if we move down, what we'll see here is we have a compound inequality containing the or statement. Now again, we are simply going to solve each simple inequality by itself and graph each one of those separately. You can see in this case that the or statements don't have an overlapping portion. They both go towards infinity in the opposite directions. And so what this means is that the solution, whatever you get for the variable, can make either one of the inequalities true in any given particular situation. And so if you recognize that the and tends to create this bounded interval and this range bound interval, and the or statement tends to create solutions that are going opposite directions to positive and negative infinity, you can quickly identify the type of compound inequality you're looking at. So alright, let's go down and use those examples to help us solve sample problem number 3. So if you go ahead and take a moment to finish that and come back and take a look at the solution. Okay, so I'm going to work part A. We have an and compound inequality, and I'm just going to work it within the context of that. So remember, since we have it in collapsed form here, if I add 1 to the middle term, I also have to add 1, to both the outside terms as well. And so that's going to leave us negative 3 is less than 3x is less than or equal to 6, and now I will divide all parts by 3, leaving me negative 1 is less than or equal to x is less than or equal to 2. And so I have this compound inequality that's simplified. It's an and statement, so and you can really look at this part here and see that the x is between the negative 1 and the 2, and that can really help me graph this. And I'm not going to get super involved with my graph here, but that's basically telling me I know it's all the values in between negative 1 and a positive 2. Since it's equal to, I'm going to be using the closed bracket off here, And I'm just going to use a highlight to represent the solution set. Now, to write that in interval notation, these brackets more or less drop down perfectly for my interval notation with the bounded interval using the endpoints as the numbers. So that is a good example of an and compound inequality. Now let's move on down to this or compound inequality. And again, we just want to work each of these simple inequalities separate of each other. And so I'll just go ahead and do that at this point. Okay, and you can see here that in the first simple inequality we were dividing by -3, so that changed our sign for us. And then in the second one it was just a straight inequality. What I did, instead of distributing first and then having to divide that 3 out later, I simply divided the 3 from the beginning to eliminate it. So I know I skipped some steps there to save some space. So now let's graph that solution. Again, here I can look at these individually and see, and you got to be careful, all the x values are greater than 2, and so it's not equal to, so that's going to be an open interval, and that's going to go on infinitely in that direction. And then simply enough, x is going to be less than or equal to 0, so all values less than or equal, so I'm going to use that closed version, and the solutions will be moving that direction to infinity. Now, because of the fact that we don't have a bounded interval, we have 2 separate solutions, we have to write it that way. And so I can use the graph as a nice visual to write my solution set in interval notation. And so I have an open interval here with -infinity to 0, and then a closed one, and then an open one with the 2, and an open one with the positive infinity symbol. But since both of these are part of the total solution set, they can't stand alone individually, so we have to combine them together with our union symbol. And that's a pretty terrible looking union symbol. Try that again. So just the simple little U. So our interval notation would be that entire statement. Okay, so that's a good look at some compound inequality.